Hello, I am Dr. Contour, and today we will be going through your mountaineering book, teaching you about the different kinds of maps and how to read them. We're going to go to page 83, the map. No mountaineer should travel without a map or the skill to interpret the map into information about trails on the route. A number of different types of maps are available. Relief maps, they help in visualizing the ups and downs of the landscape, and they have some value in trip planning. Land management and recreation maps are published by the U.S. Forest Service and other government agencies and by timber companies, are suitable for trip planning. Climbers' sketch maps, such drawings can be effective supplements to other map and guidebook information. Guidebook maps, this is a guidebook. They generally contain useful details on roads, trails, and climbing roads. Topographical maps, essential to off-trail traveling. Topos are the best of all for climbers. They depict topography, the shape of the Earth's surface, by showing contour lines that represent constant elevations above sea level. Some are produced by government agencies, others are printed by private companies with special emphasis on trail and other recreational features. This is one of them. How to read a topographical map. Latitude and longitude. A measurement east or west around the globe is called longitude. A measurement north or south is called latitude. Longitude is measured 180 degrees east and 180 degrees west. Starting at the north-south line, the meridian, that goes around Greenwich, England, latitude is measured 90 degrees north and 90 degrees south, starting from the equator. This system allows each place on the planet to have a unique set of coordinates. For example, New York City is situated at 74 degrees west longitude and 41 degrees north latitude. The scale of a map is a ratio between measurements on the map and measurements in the real world. For example, 1 inch equals 1 mile. The contour lines, which I have on my chest, are the heart of the topographic map. Is the overlay of contour lines, each line indicating consistent elevation as it follows the shape of the landscape. In mountain areas, this interval is often 40 feet and 80 feet on 15-minute maps. One of the most important bits of information a topographic map reveals is whether the route will be uphill or downhill. If the route crosses lines of increasingly higher elevations, it is going uphill. If it crosses lines of decreasing elevation, the route is going downhill. Flat or side hill travel is indicated by a route that crosses no lines remaining within a single contour interval. This is only the start of the picture that contour lines paint of an actual route. They also show cliffs, summits, passes, and other features. Which, on here, this would be a cliff. This would be like a downhill section. This would be like a plateau or flat area. And this would be another small hill. Flat areas. They have no contour lines and they're very far apart. Right here. Flat area. Gentle slopes, widely spaced contour lines, but they still keep going. Which is right there. And steep slopes, closely spaced contour lines. Which is right there. Which would indicate like a really steep hill or a cliff if they're really close together. Ridges or spurs. Contour lines of a pattern of US for gentle, rounded ridges, and V's for sharp ridges. The U's or V's point downhill in the direction of lower elevation. Saddles, passes, or cols. An hourglass shaped with higher contour lines on each side indicating a low point on a ridge. Which is right here, looks like an hourglass. Other map information. Topographic maps do have certain limitations. They do not show all the terrain features that you can actually see on a route because there is a limit to what can be jammed onto a map without reducing an unreadable clutter. Thank you.